Okay, good day everybody. Welcome back to another session of our education program. Konnichiwa. Thank you for spending your time again with me. So today we are on our next session 1.3. So it's still a basic session about the training of the heat transfer unit, cooling and charger cooling system. So we go more and more in details, step by step, into the different parts, and with some points of analyzing as well on the visualization, so that we exactly know where we can find what component, how is the function, where could be trouble, where we should do maintenance. So we go step by step deeper into the material. Okay, so let's move me out of the way and let's dive in. Let me move it to that side. Okay, our topics today: heat transfer unit, equipment protection and adjustment. Charge air cooler, equipment protection and adjustment. Exhaust gas heat exchanger, function, water flow, and what different protection systems are in. The emergency cooler equipment and the function for sure. Then some points of maintenance monitoring of water filter, dirt trap, water pressure flow, and as well expansion tank. Here again, some shortcuts of definition. So we should know already forward flow, L like FF, return flow, RF. Then we have temp for temperature, DET for the expansion tank, then FC frequency converter, PHE plate heat exchanger, EGHE exhaust gas heat exchanger, charge air cooler with CAC, PLC, the programming logic controller of the CHP. Then we have the PPC, so that's the panel PC, and MAN is manual mode, and the VSU, like the visualization software on the panel PC. Okay, so here we have a water flow diagram. So we have different cycles. I think we have to make my a little bit smaller. Let's get down. Okay. Okay. So we have the engine cycle. Let's see if we can do it. We have the engine cycle. The engine cycle is the cycle where we have the engine pump, it's that pump, running through the engine, and the forward flow goes out again back into hydraulic separator. We come back to the equipment later on, step by step. As well, we have the first stage of charge air cooler. So we're using the return flow or to the engine as well to use it and heat up the forward flow, what goes back into the hydraulic separator. So we have heat supply from the engine and we have heat supply from the first stage of charge air cooler. Okay, then we have the primary circle. The primary circle starts here in the hydraulic separator. We're running through the primary pump, through the exhaust gas heat exchanger, then to a filter dirt trap string, through the plate heat exchanger. Here get the heat transferred to the plant or to the client. The cold heat or the cold water will come back from the client or from the plant, runs back to the hydraulic separator. That's that flow. The next one what we have is the bypass plate heat exchanger. Yeah, I'm talking about this bypass. It's parallel to the plate heat exchanger. This one with a three-way valve. And for sure, in case that we don't have heat supply to the client and the hot water will come back to the engine, it's too hot, so we exceed our target temperature, we have here a cycle that runs through the emergency cooler as well with a three-way valve. So this is the cycle of the emergency cooler. Yeah? And the last part I explained already, sorry, is the first stage of the charge air cooler, what is parallel to the engine and get heat supply to the forward flow to the hydraulic separator. Okay, we know already the charge air cooler system, so we have the flow diagram. We have here the first stage, what we saw on the other page as well, parallel to the engine. Then we have the second stage, it's here. So we have the charge air cooler stage 1, is that area here. We have the charge air cooler 2, that's that area down here. The charge air cooler 2 stage is connected with the safety module system, which has a three-way valve and the pump and an external radiator cooler. So we can see here the second stage is a separate closed cycle. The first stage is connected to the cooling system of the engine, but the second one is a separate cycle which is not connected to the cooling system of the engine. This picture we know from the last video already. So we have the intercooler with the two stages. We have stage 1 connected to the engine. We have stage 2 connected to the external radiator cooler. So our charge air cooler is this here in front. The inlet after the turbocharger, where we get the mixed air into the intercooler or the charge air cooler, and the gas runs through here, get out of here into the engine. The first stage of the charge air cooler supply approximately 20 kilowatt thermal power to the internal cooling system. That means we use the first step of charge air cooler to get another 20 kilowatt thermal power out of the charge air and use it in our supply system to the client. So we will come back later to the flow rate as well. So the first stage charge air cooler need a flow rate of 60 liters per hour. This will be adjusted with a tacho setter. Here we have the second stage. The function should be clear from the last video. So the intercooler by themselves is to cool down the gas mixture before it's reached the engine. So the second step is to get the rest of the heat cooled down, that the charge air temperature get on target. The standard target, the ideal target, is the 40 degrees Celsius. And the flow rate of the second stage is 70 liters per minute. Okay, now to the tacho setter adjustment. We have here a manual from the tacho setter. With the tacho setter, to measure the flow rate, it's all in liter per minute. The flow rate here is important, we can only measure the flow rate if the pump is in operation. So the water pump must be circulating the water, otherwise we cannot measure a flow rate. So the water pump can be either run if the engine or the CHP is operating, or we can start the pump manually, either with the rail or the connector, or via the visualization software. With this small tube, if we press the red handle here, we can measure the flow rate. We will see then a white thin plate inside, what is floating to a level here on the scaler, on the scaling. And there it shows how much flow rate we have run through the tacho setter. The flow rate can be adjusted via this valve. So through turning that shaft, we will adjust on the different levels. So we have a 0 point level, A, B, C, and D level. Through that scaling over the adjustment of that, it's like an internal valve, what will use the diameter of the flow so that we actually change the flow rate. So we can adjust that over this shaft or valve, and we can check again here that we reach the right flow rate, what is required. The flow rate is very important that we have a focus on that. If the flow rate is too slow, we get too much heat, too much high temperature, and not much flow through the system. So then the heat transfer cannot work properly. Okay, so we have here our charge air cooler control and safety module system. So the function should be clear from the last video, from the previous videos actually. We have here a radiator cooler. The radiator cooler starts with the CHP and operates on a minimum fan speed. We have the first step of control for the temperature, of the charge air temperature. The adjustment will take over from the freeway valve. This is that part here. This freeway valve will first control and adjust that we reach our target of 40 degrees Celsius charge air temperature. And if this valve reach the maximum opening position, then the radiator cooler fan speed will start to increase to get back the temperature on target. Now we have the different components on the charge air cooler system and safety module. Let's say go quick through the points. It's quite easy. So we have here a thermometer to measure the temperature of that pipe. We have the freeway valve with the actuator motor. Number 2, we have the dirt trap filter. It's with a ball valve. It's here. From the ball valve, we go through the balancer valve. So this is the tacho setter, where we can measure the flow rate and adjust the flow rate. Point number 5 is here another temperature measurement tool, so a thermometer. Number 6, so it's actually only a connector with a thread, so a screwed connector. Number 7, here we have the air bleeding valve or air release valve. This is an automatic release valve to get the air out of the system. Number 8, I have here, that's that one with the red cap. This is the safety overpressure valve. In case that the pressure in the system exceed the limit of this overpressure valve, the overpressure valve will release through that pipe, that's number 9, release water so that the pressure will drop. So in case we have some problems or problem with the expansion tank, that the pressure cannot compensate, before we get a too high overpressure in the system, this pressure valve will release water and pressure to operate on a safe pressure value. Number 10, yeah, that's the frame, foot. Then number 11, the expansion tank. Number 12, here we have the cap valve of the expansion tank. I will go into that in the video later. Number 13, we have a pressure gauge here that we can see directly the pressure as well in that cycle. Another screw connector is actually the connector point to the charge air cooler. Then we have a filling drain, number 15. It's that one. So we can fill and release water here. We have a ball valve, number 16. It's here. I assume that this part of the items are not installed at your place. I don't think we need it at your place. So it doesn't matter. We go through that as well. We have number 17, another balancer valve. So the El Taco setter. Then we have number 18, another ball valve, so a ball cock. Then we have the circulation pump, number 19. Number 20, another thermometer. Number 21, ball valve. Number 22, another ball valve. So we have the connection to the intercooler, and we have the connection to the radiator cooler. So later on to cool down the water of the charger. So in the charger cycle, we have the circulation pump. That's that one. And this pump starts and stops with the CHP. We have the three-way valve, what can control the circulation through here and how much volume goes through the radiator cooler. And the radiator cooler and radiator fan, the three-way valve and the fan speed will be controlled by the PLC.